In the absolute silence that stretches far beyond Neptune's orbit, the Voyager spacecraft continued to advance, slowly gliding through a darkness no human had ever witnessed. The mission predicted that nothing existed there beyond empty space, cold dust and temperatures near absolute zero. For this reason, when the first data began to indicate unexpected levels of energy, heat, and activity, scientists at the North American Space Agency came to believe there were sensor failures. How could a region so distant from the Sun show signs that resembled the behavior of a star in combustion? To understand this extreme frontier, it is necessary to revisit the entire trajectory of the Voyager probes. Launched in the year 1977, the Voyager 1 and Voyager 2 spacecraft had the initial objective of exploring the outer planets of the solar system and revealing to humanity what existed beyond the reach of terrestrial telescopes. Each carried advanced scientific instruments, high-precision cameras, and a golden record containing sounds, images, music, and messages representative of life on Earth. No one at that time imagined that these probes would continue operating for more than 4 decades, crossing regions never explored by any human creation. The mission was only possible thanks to a rare alignment of the outer planets, a phenomenon that occurs only once every 176 years. This configuration allowed the Voyagers to use the planet's gravity as a boost, saving fuel and drastically extending the mission's reach. Voyager 1 revealed unprecedented images of Jupiter, showing storms larger than Earth itself, and of Saturn, whose rings shone like ice suspended in the cosmic void. Voyager 2 followed a longer route, becoming the only human spacecraft to visit Uranus and Neptune up close, offering the first detailed images of these bluish, distant worlds. After these historical encounters, both probes faced a silent decision. There were no more planets to visit. All that remained was to end the mission or allow them to continue advancing towards the unknown. The space agency decided to let them go. Even beyond Neptune's orbit, the Sun still exerted influence through the solar wind, a constant flow of charged particles that propagates in all directions. This wind creates an immense magnetic bubble called the heliosphere, which surrounds the entire solar system and acts as a shield against cosmic radiation from the galaxy. Like every shield, the heliosphere has a limit. This point, where the solar wind begins to lose strength as it encounters the interstellar medium, is called the heliopause and marks the true frontier of solar influence. For decades, scientists only speculated about its nature. Some imagined a calm and silent transition. Others believed in a turbulent region where opposing forces would violently collide, creating an invisible barrier. The Voyagers were designed to reveal this truth. As they moved away from Earth, their instruments measured temperature, plasma density, magnetic fields, and energetic particles. Over the years, the data began to show that the solar wind progressively weakened. The energy that once flowed freely began to be pushed back by the interstellar medium. In simple terms, our star's wind was colliding with the galaxy's wind. At this point, the sensors registered the so-called termination shock, a region where the solar wind abruptly slows down and the plasma is compressed, like ocean waves colliding against a frozen coast. The heliosphere proved to be dynamic, pulsing according to the Sun's activity. When the star became more active, the bubble expanded by billions of kilometers. When it calmed down, it contracted again. In 2012, Voyager 1 crossed this frontier and made the most surprising discovery of the entire mission. The instruments indicated an extreme increase in plasma temperature, reaching almost 50,000 degrees. Nothing so distant from the Sun should present such a level of heat. Still, the data was consistent, clear, and continuous. These were not flames like those known on Earth, but extremely energetic particles, moving at such high speeds that they carried an enormous amount of thermal energy. This region came to be called the firewall. It was not a physical wall, but a limit of pressure and energy, where the solar wind is compressed by the interstellar medium gas. The plasma density increased dozens of times compared to the space behind the probe, while the speed of the solar wind dropped practically to zero. Years later, Voyager 2 crossed the same region, and confirmed the same phenomena, proving that the firewall was not an isolated event, but a permanent characteristic of the solar system. Another unexpected discovery involved the magnetic field. Scientists believed that upon crossing the heliopause, the probe would encounter a completely different magnetic field, oriented in another direction. However, the data showed that the internal and external fields were almost perfectly aligned. This indicated that the boundary between the solar system and interstellar space was not an abrupt rupture, but a smooth transition where the magnetic lines of the Sun and the galaxy connect like threads of the same cosmic fabric. This energetic frontier plays a vital role in protecting Earth. The heliosphere deflects most cosmic radiation, preserving the atmosphere and making life possible. Without this shield, galactic particles would destroy essential molecules, remove the ozone layer, and expose the planet to lethal levels of radiation. The Voyager's measurements allowed us to understand how solar activity strengthens or weakens this protection over time. The discoveries also expanded the understanding of other stellar systems. Each star has its own protective bubble, called an astrosphere. If the stellar wind is too weak, its planets are exposed to radiation. If it is too strong, their atmospheres can be stripped away. The Sun presents a rare balance, strong enough to protect, but stable enough to preserve, which may explain why Earth has remained habitable for billions of years. More than scientific data, the Voyagers carry a deep symbolic meaning. Even billions of kilometers away, their signals still reach Earth, proving that the solar system's frontier is not an end, but a transition. They revealed that the Sun is not just a source of light, but a guardian, and that our existence occurs within its cosmic breath. Beyond the firewall, the two probes silently continue their journey through interstellar space, carrying the voice of humanity through the stars. If the boundary of our Sun burns with so much energy and life, how many other fires still await discovery in the unknown depths of the universe? Thank you for watching. While you're here, don't forget to like and subscribe to the channel. Click on one of the recommended videos on the screen for more incredible information. See you there.